So I have class at 8 o'clock, sir.
Okay, no problem. I will send you the record. No problem. Let's see. I'll finish 8:15, something like that. Let's see. Okay, look at this one. The interesting part of this calculation is Avogadro constant. Avogadro, the man who introduced this constant. Normally in physics, you use this K is a constant, but here in calculation, Avogadro is used as a constant. What's that actually? Lots of people have problem for connecting. I don't know why. Right. So Avogadro constant is says what actually? Look at this one. This is interesting part. Carbon. What is that? Relative atomic mass of carbon is how much? 12. So if you take 12 gram, look at that. Interesting part. It will have 6.022 into 10 to the power 23 atoms. Look at this one. The relative atomic mass of hydrogen is 1. If you take 1 gram, and it will have 6.022 into 10 to the power 23 atoms. Look at this chlorine. The atomic mass of chlorine is 335.5. So if you take 35.5 gram, it will have 6.022 into 10 to the power 23. If you take magnesium relative atomic mass 24. So if you take 24 gram of magnesium, it will have Avogadro constant 6.022 into 10 to the power 23 atoms. Interesting one. See, argentum, we can call this one silver. The silver relative atomic mass is 108. So if you take 108 gram, then it will have 6.022 into 10 to the power 3 atoms. Interesting one. What's that actually? 12 gram. Wow, 6.022. 1 gram, that's also 6.022. 35.5 gram, that's also 6.22. 24, that's also. 108, that's also. Interesting one. What is that? If you take any atoms or molecule which has equal amount of relative atomic mass. For example, if you take potassium, the potassium relative atomic mass is how much? 39. So if you take 39 gram, then it will have 6.022 into 10 to the power 23 potassium atoms. Actually, you must know what is the main point here. Avogadro constant can be called as a L, and that constant is 6.022, which means any atom or any molecule which is same amount of which is same number of atoms or molecule, and that will have a constant value of atoms or molecule. For example, if you take sulfur atomic number relative atomic number 32. So if you take 32 gram, it will have this number. If you take potassium relative atomic mass 39. So if you take 39 gram, then it will have number. Look at this one. We take same number which is related, same number in gram, same value in gram, and that has atoms or molecule same number. which means this is what? What's that? The constant. This is constant value. For every amount or every value of every relative atomic mass in gram, it is constant. That's this constant was introduced by Avogadro, and that's why it is called Avogadro constant. Interesting one. For example, I'm going to give something here. Listen, we will be talking about mole, right? But I'm not going to talk about that mole, but you must know this is one mole. I'm going to move whiteboard. If you come to this, if I take sodium, right? Take this point. The sodium relative atomic mass, how much? 23. So, if you take 23 gram, this will have Avogadro constant number. I used to use L here. OL. This L value is what? 6.022 into 10 to the power 20. You must know, very important here, this amount or the same value in gram of any atoms or molecule. Look at this one. Same value of relative atomic mass in gram would be called that 1 mole here. Here 1 mole of sodium is what? How much? 23 gram. Take the idea simply. If I take calcium here, calcium relative atomic mass 40. So if you take 40 gram, it will have Avogadro number of calcium atom. So this is equals to how much? 1 mole. If you take 2 mole, then how about the mass of calcium? 2 mole. 40 into 2. How much? 80 gram. If you take 10 mole,
400.
400 gram. I can move it other way around. If you take to 80 gram, it's 2 mole. If you take 2 mole, it's 80 gram. If you take 10 mole, 40 gram. If you take 40 gram, 400 gram, 10 mole. Same as something like that. If I take, for example, sulfur atomic mass, relative atomic mass 32. So if you take this 32 gram, it will have Avogadro constant number, and this 32 gram also 1 mole. So if you want to take 2 mole of, sulfur, how much of mass you should take? 32 into 2. How much?
64.
64 gram. So we have an equation to find that, but to understand, I'm talking this one. If you come to this, again, another important thing, this is another interesting point, Avogadro constant. But for molecules, look at this one. Anybody have connecting problem? Please, I will send this video, no problem. Please let me know the network problem in your area, right? I want to know that. Right, let's see. See this one, carbon dioxide. The relative. This is. Can you use carbon dioxide for relative atomic mass? Never, because this is a molecule. I can use what relative molecular mass of carbon dioxide. How to find 12 plus oxygen relative atomic mass 16 into 2. How much? 44. Interesting one is if you take 44 gram, how many carbon dioxide molecule? Avogadro constant. 2, the relative atomic mass of H2, 2. If you take 2 gram, Avogadro constant. Relative atomic mass of Cl2, 35 into 2, 71. If you take the 71 gram, Avogadro constant. The relative molecular mass of ammonia, 17. If you take 17 gram, Avogadro constant. The relative molecular mass of glucose, C6H12O6, 180. If you take 180 gram, Avogadro constant. Simply, I can say this is what? If you take 180 gram, this is also what? 1 mole. This is also what? 1 mole. 1 mole. 1 mole. 1 mole. If you take this 6SO2 sulfur dioxide, 64, the relative molecular mass. If you take 64 gram, and it will have what? Avogadro constant. And that would be 1 mole. If you have sulfuric acid 98, the related molecular mass, if you take 98 gram, that's also one more interesting part. Don't worry, there is an equation to find these all, but realize this one. If you go to A level, there is a chemistry, biology, math stream, and also science for technology stream. Everything is there. These all are there, right? Please understand them. Come to this point. I'm going to move wide here, right? See here, for example, if I take H2. H2 is a what? It's a type of molecule. How to find the related molecular mass of this H2O? Come to this one. Hydrogen, how much? 1.
1.
Oxygen, 16.
16.
And 1 into 2 plus and 16. How much
18.
relative molecular mass is? Look at this one.
18.
Why I'm not using relative atomic mass? This is not atom. 18 relative molecular mass. If I take this 18 gram and this is how many molecules you will have this in 18 gram? Avogadro constant. And that is L. What is the number? 6.022 into 10 to the power 23. And this will be 1. What is this 1 mole? 1 mole of H2O molecule. 1 mole of H2O molecule. Not H, not hydrogen. Interesting thing there. That's why lots of people are confusing that one. There is a question, I think 2016, iron Fe2O3, which impurities? There is a question in calculation. The best question. We will do that one, no worries. Look at this one. For example, if anyone wants to note, please let me know, then I can take time to note. You don't need to note this one. You just take a screenshot, then note. That's all. If you come to, for example, chlorine gas, see. Let's move not something like that. Chlorine. Okay. Can somebody say one molecule? Right. Okay. Propane. C3H8. Propane. Methane propane. How to find the related molecular mass of this C3H8? Carbon 12, hydrogen 1. So then 12 into 3 here plus 1 into 8. How much now?
44.
44. This is related molecular mass of propane. But if you take 44 gram of propane, and that is 1 mole, and it will have how many propane molecules? That is L. You must know this combination, very easy. And if they give, for example, look at very easy method, 44 gram of propane molecule, and this is 1 mole, and it will have 6.022 into 10 to the power 23 what molecule? C3H8 molecule. Simply you can, here if you take 2 mole, how about the mass? 88. How about the
88.
molecule? 2 into 6.022 into 10 to the power 23 what molecule? C3H8 molecule. This is the very important part of this one. The relationship between gram, molecules and mole you must know. Let's do another example. For example, not only the molecules. For example, C6H12O6. I'm going theory fully, yeah. It's not about theory, but I can't move without talking about theory. This is what glucose molecule. What is the chemical altogether? If you found this one, carbon 12, you don't need to remember this 12. They will give in all of them, no problem. Hydrogen 1, oxygen 16. These are what? These are what? These are what? This is 12 what? Relative atomic mass of carbon. This 1 is what? Relative atomic mass of hydrogen. This 16 is what? Relative atomic mass of oxygen. Using this atomic mass, we are going to find the molecular mass of C6H12O6. Carbon 12 into 6 plus H1. How many hydrogen? 12 hydrogen, 12 plus 16 into 6. The answer would be 180. The relative molecular mass of this glucose is 180. So, you just take this one, take the point. 180 gram is equal. What's that? 1 mole. It will have 6.022 into 10 to the power 23 what molecule? C6H12O6 molecule. Simply, if you take 90 gram of glucose, how about this one? How many mole? How about this one? Half into 6.022 into 10 to the power 23. What molecule? Glucose molecule. If you take 1,800 gram, How about the mole? 10 more. How about this Avogadro number of molecules? 6.022 into 10 to the power 23 into how much? 1, 10.
54.
Then I can write what? 6.022 into 10 to the power 24. Here is power 1. Are you all understanding the connection between these molecules and the moles and the number of molecules or atoms? You must know this connection. If you come to this, for example, sulfur. Sulfur is what? 32. We are talking about the molecule. I'm going to talk about the atoms now. This is what relative atomic mass of sulfur. If you take 32 grams of sulfur, and that would be what? 1 mole. It will have what? 1 L. If you take 16, how about this one? Half mole. How about this one? L by 2. L by 2 means L is what? 6.022 into 10 to the power 23 over 2. What's the answer? 3.011 into 10 to the power 23. Don't cut this 2 and 2 and this is 1, then 6.021. That's not, it's all about science, not the maths, right? Seriously, subtraction or dividing, everything is tough for grade 11 and 10. I think in government syllabus people, that means the government students have so many problem of this, but these things. They know every science, every maths, but they can't what divide. It's really tough. So don't do like this one, 2 and this 2 and this 2, or this 2 and this 2, something like that. So it's a half of 6.022 into 10 to the power 23. That's all. So this is how you must know the very important things that we have discussed here. Okay, let's move. So another one, the term is molar mass now. Interesting one, the mass of 1 mole of any compound is called what? Molar mass. 1 mole of any compound. Look, 1 mole of any compound. How to find the 1 mole of any compound? For example, carbon dioxide. What is the mass? Relative mass, molecular mass? 44. So, the 44 gram is what? Is what? 1 mole. Molar mass says is what? Mass of 1 mole of any compound is called molar mass. The unit gram mole minus 1 or kilogram mole minus 1. For example, if you come to this example, relative atomic mass of sodium 23, so the molar mass of that sodium is 23 gram mole minus 1. The difference between these two are very important. Come to this one now. Relate the molecular mass of carbon dioxide 44. So the molar mass, the term molar mass can be common for atoms and molecules. So the molar mass is 44 gram mole minus 1. That is what you must know. For example, if I take ammonia molecular mass is 17, then the 17 gram is what? 1 mole, and the molar mass is 17 gram mole minus 1. 17 gram mole minus 1. Look at this one. Now, the next term we're going to talk about the mole. Mole is can be found. This is very important part of this class. Mole is can be found using three equations. This equation, number one, amount of any substance or number of mole is equal given mass over molar mass, capital M. So that there are three equations should be useful to find the amount of substance, amount of mole. N is equal capital simple M given mass over molar mass. Given mass over molar mass, this is the equation you must know. What is the unit of this molar mass? Gram mole minus 1. Second equation, if you know here, second equation, the mole is number of atoms or molecules ion over Avogadro constant. Second equation you must know. Simple N is equal number of atoms and Avogadro constant. I'll send this PDF, no problem. This one is these equations. These two equations are very important to do these calculations in this chapter. N is equal given mass over molar mass. N is equal number of atoms or molecules over ions. And the third equation you may have studied, you know that the mole, to find the mole, and you must know that mole is equal concentration into volume. Where you may have studied this equation, grade 11, chapter number 3. Have you studied concentration equal mole over volume? Have you studied? C is equal N over V. Mole is E over V. For example, 2 mole. And if they give volume 2 decimeter cube, we will study this one. Huh? We will do the question for this one. Then the concentration would be 2 over 2, 1 mole per decimeter cube. All decimeter minus 3. So from this equation, I have multiplied by this one. N is equal CV. You know, curriculum vitae. You must easily understand. So there are three equations you must know that. What's that? The mole, to find the mole is equal given mass over molar mass. And second one, mole is equal number of atoms or molecules or ions over Avogadro constant. And the third equation, N is equal CV. That's all. If you know this equation, these all very completely, then we can move to question part. Anybody have any doubts? Please ask me.
Excuse me, sir.
Any doubt?
Excuse me, sir.
Yeah.
So if they ask the moles of oxygen atoms in 1 mole of carbon dioxide, what's the
We will have that kind of question, right? No worries. We will have that kind of questions. Then you can understand, right? Right.
okay, sir.
Let's move to the question part. So please take a small paper and do this question, and that is the very good way of studying. The question number one. I used to use this type-wise question, and we will do this past paper question also. No worries. Type one. Type one says what? Write common chemical formula of for relative atomic mass. Can you write? It's easy one. Why I ask this question? Normally these kind of question come in MCQ with 4 multiple choice. The right common chemical formula for relative molecular atomic mass. What is that? Relative atomic. Don't write short wise, and I'm just writing. Atomic mass, relative atomic mass is equal. What's that? Just count. Mass of an element of atom. Element, mass of an atom of element. An atom of element. Please write and practice. It's really tough. Uh, if I ask someone, so if I ask the lots of students I have asked, what is the difficult units in 35 units in ordinary level? Grade 10, the 20 units, and the grade 11, that's 15 units, altogether 35 units. I have met so many batchers, and I asked so many people what is the difficult part of in ordinary level science. They used to say what this chapter. But it's very easiest chapter. If you go to past paper, please use past paper to use this one, right? Use the past paper to study this unit mainly. Give me a 1 minute. Okay. Mass of one atom over, what's that? 12C carbon atom, 12C carbon, mass of atom or mass of element into, what's that? Into 1 over 12. This is the answer. But sometime they will cut this one. Listen here. Sometime they will cut this one 24, and if they give 24, sorry, 12, wait. Sometime instead of this 1 over 12, you know that if 12 move upwards, then what about this one? 12. If they give it an MCQ, is it correct? Yeah, correct. Sometimes they will give what? Sometimes they will give. They are trying to confuse always. 2 over 24. Then you will confuse where is 12, where is 12, where is 12. So if you cut this 2 over 24, then 1 over 12. Sometimes they will put here starting point. That's also correct. So please understand, they will ask this question only where in MCQ or else structure, and they will ask to write only this equation. So look at this one. This is what I asked. Relative atomic mass. Mass of an element of atom 1 over 12 into mass of a 12C carbon atom. Why we are using 12C? There is one 14C carbon. This link will expire by 1 minute. We will go to another link. Stop it.